Well, hello, calculus students and seekers of truth. Let us continue and do one more example here on the topic of basic derivative rules. And as before, in the previous video, we are going to look for not the derivative, but rather the antiderivative in this case, right? Because we're given f prime and we're asked to find f. So to find f, using the power rule, we're going to take x and raise it and increase the power by 1, and then we still have this coefficient of 3 in here, but then remember we need to divide the whole thing by this new coefficient as well. Okay, and for the terms when you have 2 right here, it's just going to become 2x, and remember we're going to add a constant at the end. So we can simplify this and we can say that f of x is equal to x cubed minus 2x plus some constant. And we can check this on the side really quickly. As you get more familiar with this process, maybe you don't have to check anymore, but the derivative of x cubed is going to be 3x to the second power. And then the derivative of negative 2x is just going to be negative 2. So we're good on that in that regard. Okay. Now we're actually given some more information. Okay. So when we're told more information, we can actually use this to figure out the constant. That's what this right here has a kind of a special name. We call this the initial condition. It might not be an initial condition. Awfully refers to f of 0, but it could also apply with some other numbers as well. It just depends on the context of the problem. Here we're not working with a practical application, so anything can be an initial condition. So we know here that f of 1 must be equal to 4, right? But f of 1 means substituting in 1 for x. So 1 cubed minus 2 times 1 plus some constant. And all of that must be equal to 4. So this becomes 1 minus 2 plus the constant is equal to 4. So it's not hard to see here. 1 minus 2 is going to be negative 1. Add that to both sides, and we get that c is equal to 5. So our final solution is going to be, let me change up some colors here, f of x is equal to, and just following here, f of x is equal to x cubed minus 2x plus 5. Okay. So let's see just a little bit more detail here why that works. Okay, so why this is a final and perfectly good solution. If we take the derivative, we do in fact get 3x squared minus 2. If we plug in 1, we do in fact get 4. You get 1 minus 2, which is negative 1, plus 5 is positive 4. So all of the information, all of the requirements that we were given in the problem has been satisfied. Okay? So this is called a specific solution. Right? In the last video, we discussed, you know, there's a general solution to this problem that in the last problem we weren't given any initial condition, so we had to settle for the general solution. There's just some placeholder here for a constant. In this particular problem, we know enough information. We were given this extra bit of information so we could use it to figure out the specific value of c. As always, thank you for watching. Keep working hard and have a wonderful day.